Hi, in this presentation I will talk about glucose and palmitate and when those substrates entering glycolytic system and oxidative system, energy will be produced during exercise. Here we have some sources of carbohydrate and fat. Um, Sport drinks, source of sugar, which will be converted into glucose. Sweet potato and pasta, source of carbohydrate, will also be converted to glucose and stored in our body. Fat, we have milk products that will be stored in adipose tissue and used as energy as well. To illustrate some of the pathways, here we have the metabolism of glucose. In green we see the chemical reactions, and through these chemical reactions we're gonna have a production of ATP. There's a specific number for this pathway, specific numbers of ATP that will be produced. In pink we see the metabolism of fat, so fatty acids and glycerol. Through the lipogenesis will also provide energy. So this substrate will be converted to ATP, and through each of these we're gonna have this system, we're gonna have a specific number of ATP. One molecule of glucose in the blood, or one molecule of glycogen in liver or muscle, it will give us throughout this system, this pathway, 32 to 33 ATPs. One thing that I want to say, to highlight, is the importance of the coenzyme NADH. One NADH gives us 2.5 ATP. Also, energy transferring to electron transport chain. With that, more energy will be produced. So every time you see any ADH, also FADH, we know that there's a production of ATP as well as energy being transferred to electron transport chain. Following the steps over here, glucose or glycogen, and goes through different steps. As we see here, the pyruvate, acetyl-CoA, until we get to the Krebs cycle, and then there's more production of energy in this part of the process. This slide shows us the beta oxidation. The beta oxidation now uses fat as source of energy. So I go back here to this slide to show the fatty acid entering that system in order to produce energy. Through the beta oxidation, in the end, we can have 108 ATP being formed during exercise. Once again, we see NADH, and we know that ATP will be formed. So in this first stage, we have 7 steps. So 7 chemical reactions that started with the palmitic acid 16 carbon chain. This chain can be up to 24 carbon chain. The 16 carbon chain is the most common one. When we arrive to the stage 2, we will have 8 acetyl-CoA, which will give us 8 full Krebs cycle. So a specific number of ATP will be formed in the system. The next slide here will show us that the fat oxidation, there's two different ways. Triglycerol will be stored in the adipose tissue, as I said before. And the triglycerol can be converted into glycerol and fatty acid, as I explained before. So fatty acid enters beta oxidation. Glycerol is a little bit different. It goes down to a different path and then enters citric acid cycle or Krebs cycle. They are the same. When our body uses glycerol down to Krebs cycle, we will have a production of 460 ATPs. So in this slide, we will see how exercise intensity and the duration will influence on ATP production. So the glycolytic system, a full glycolytic system breaking down the glycolysis will provide during exercise 32 to 33 ATP formation. So anaerobic intensity will mainly use glucose as source of energy, and then through the system we have 32 up to 33 ATP being formed. Some exercise to illustrate, some activities to illustrate that we see jumping and then sprinting using fast twitch muscle fiber. For instance, when a person is exercising at a high intensity from sprinting to endurance mode, glycolytic and oxidation will contribute to produce ATP. So we can initiate that exercise in one system, glycolytic system, and move on to use the oxidation system, knowing that the glycolytic system using one molecule of glucose gives us up to 33 ATPs. In terms of anaerobic intensity, where it requires the use of oxygen to breaking down the substrate, we also call it the oxidative phosphorylation system. We can use the system can use glucose and fat to produce ATP. For instance, 30 minutes of moderate exercise at 65% intensity of VO2 max. Mainly contribution will be fat as source of energy, and as mentioned previously, so when we using the fatty acid, we can have up to 108 ATP. So this system contributes with a lot more ATP compared to one molecule of glucose in the glycolytic system. Remembering that if the glycerol is used, we can have over 400 ATP being formed. So it's a very rich system when you use the fat as source of energy, of course, followed by the aerobic intensity. Dominant system during exercise for energy production. Generally, one system will lead the production of ATP, as we saw previously. We also might see a transition. For instance, 30 minute running, 10,000 meter the distance. So the oxidative system will be predominant. However, glycolytic can contribute. So interestingly, we see that no exercise is 100% aerobic, either anaerobic. I wanted to mention the role of hormones because we see here, for instance, glucagon stimulates liver glycogen breaking down into glucose to meet metabolic demands. So as I said, as explained before, glycogen can be stored in the liver and muscle. When glucose is depleted in the bloodstream, So this glucagon, this hormone, will stimulate this breaking down. Also, we see GH hormone mobilizing fat, and the use of fat for energy, primarily energy used during rest and prolonged exercise. These are the references and also the end of this presentation. Thank you.